always high honor to actually see a defense, because I know these students have worked pretty hard in classes and on a thesis or on a project. And Matt came to me with an interesting project, working as an internship with an interesting group. And so worked really hard this semester to actually pull together the technology, which is not for the faint heart, that's for sure. So today he's giving his master's project defense as opposed to a thesis defense. So what you're going to see today is the front side of a very technical project for a group, Glenn-Colusa County. So with that, Matt Collins.
All right. Hello, my name is Matt, and I will be presenting irrigation water quality, mobile GIS and survey tool for the Glenn-Colusa Irrigation District, facilitating informed water resource management.
Move the mouse over to the screen and it'll work. So now click.
There we go. Okay. So project background. The Glenn-Colusa Irrigation District is a system of canals and irrigation ditches that deliver water from the Sacramento River to water applicants within the irrigation district. And this can be for any land that's applied for, which is mainly agricultural land, particularly rice, managed wetlands, or the National Wildlife Refuge System. Water quality is collected to ensure that water provided to water applicants is the best it can be for crops, wetland flora and fauna, and livestock within the district. And then water quality data is currently collected by penciling data into the master binder, which is then uploaded to Microsoft Access and Excel, and then it's also scanned too. So just a quick literature background. Understanding what water quality means to a district like this is pretty important, because they deliver water to one of the largest irrigation districts in the state. So ensuring that they have high environmental quality and emphasizing the symbiotic relationship between land use and water quality is also very important for them. Creating hydrological models and workflows that occur over space and time are also a cornerstone for this project. The whole idea of GIS is creating a model of space and time. And then lastly, the Glenn-Colusa Irrigation District, yes, it is mainly for agricultural purposes, but the land cover and topography in the irrigation district, it varies pretty vastly, and that is the Sacramento River, and they're on the leeward side of the Coast Range. And then just the literature continued. So as the technology advanced, people started to wonder what tools such as Google Earth and the ArcGIS suite could do for water quality collection. So these tools are mainly for specific industries, but they've now become more available and they're more user-friendly, more importantly. Irrigation water is directly impacted by agricultural operations. So pesticide use is very, very apparent in the area, and it affects your water quality and even your land cover too. And so this could also be used to think of that space and time model as well. And then water quality indexes have been used to predict and track changes in irrigation systems for many places throughout the world, making sure that you have a reliable water resource every year is very important for agricultural irrigation districts such as the Glenn-Colusa Irrigation District and all throughout the state. So the purpose of this project was to create a GIS tool that could easily store water quality data collected from 2014 to the present day using a cloud-based service, which is ArcGIS Online. In order to get there, though, a few things needed to be done. We needed to first create a geodatabase in ArcGIS Pro. This was done with the data collected from 2014 to the present day. And that was all in Excel sheets, and that had to be processed in order to upload it to ArcPro. And then creating a mobile GIS service. So using Survey123 and ArcGIS field maps in order to collect data in the field and only having to collect it once. Right now, the current process, you collect it on paper, you go into the office, you then upload it into Excel and Access, and then you scan that document and it just kind of sits there until someone needs it. And then lastly, data visualization using ArcGIS dashboards. So yeah, this helps to make the process a little bit more clean. It helps the field technician with human error as well. And so here's the project concept. We have the cloud-based service here, ArcGIS Online, but it needs to start in ArcGIS Pro with data creation and cleanup. And then you can create the web app, which is essentially where that feature service stays and it lives. And then that feature service is used to create the dashboard and ArcGIS field maps and Survey123. So the project study area is the Glenn-Colusa Irrigation District. It spans from north of Hamilton City, just outside of Capay, all the way down to Williams, just south of there. And there are 20 water quality monitoring sites in the district. There are 5 locations that are on the main canal, and those serve as a baseline for the remaining sites. So these are all main canal sites here. This is the final one. But they all serve these clusters. And then the locations that are clustered are mainly drain outflow sites, and they tend to drain into natural flowing streams. Water quality is collected using the Hariba U52 multimeter. And 7 water quality parameters are collected. One thing to make sure of when you're collecting water quality, and usually and any instrument in science for that matter, is ensuring the calibration of your multimeter. So instead of, if you wanted it in Fahrenheit, you'd have to change it from Celsius to Fahrenheit, and then from Fahrenheit to Celsius. Millisiemens per centimeter, and so on and so forth for each parameter. And then this is just an example. This is the most recent water quality data collection sheet. So this is from the master binder, and here are the different parameters, and then the time, and then the date, and then each location and the route order and the station number, which are they're different in terms of driving convenience. And then one thing about this is, which is great, is the comment section. This is helpful for the survey and the field technician. There's a standardized language now where you hit a drop-down button, and there are different conditions, such as like the canal was dry, so you couldn't collect water quality that day, or the road was inaccessible. So the methods. The geodatabase creation was done through Microsoft Excel with about 1,500 data points that need to be verified and ordered by station name and ID. once this was completed, the data was then organized by station ID and the date visited along with its 7 water quality parameters. So if you can imagine station 1 and all the points of station 1 ordered chronologically from 2014 to the present day, and then station 2, the same date chronological, and then 3 and 4. When I was doing this initially, there was some null values that were discovered in the data set. And then there was at the time, there was no reason as to why they were null. I thought it was just missing data. But I went back into the water quality binder and I saw that comment section. So I went into the Excel sheet and I updated that. And then this was all uploaded to ArcGIS Pro along with the water quality point layer. And then what makes this happen is the relationship class between the water quality point layer and the data table, which is a one-to-many relationship. So here we have our data visualization. This is the ArcGIS dashboard. And this is data that was collected for point 1. So this is the main pump station forebay. And the 3 water quality parameters that the irrigation district is concerned with the most is water temperature, pH, and salinity. These 3 parameters all kind of intertwine with each other, but salinity is probably the most important because it is directly affecting crops. And if your water is too salty, then your crops will die, along with your wetland habitat. The one issue that I did have with this, and I actually have a meeting with Esri tomorrow to figure this out, is that there's an action. Once you click on each point, you're supposed to get a different graph for each parameter over time. It only works for point 1 at the moment. I don't know why. And I've tried with Dean. We sat together for hours, and we're gonna figure it out. But it's gonna be all right. And then if you notice these spikes here and here, and then there's the spikes down here for pH. My thought for water temperature was that this was not calibrated correctly because that is about 75 and 76 degrees. So my thought was that was in Fahrenheit. And that was what the rest of the engineering department thought too. But I just wanted to keep the data consistent throughout with what I had. And this salinity measurement was around the same time. So I'm just thinking it was also the multimeter itself having a bad day. And then the pH being acidic that day, just another reason why it could be the multimeter, but it also is likely the water itself. And the Survey 123 and Field Map tool, this was designed directly with the field technician in mind, how to make their life easier and how to make their water quality route, which already takes the entire day, easier so they don't have to hustle back to the office to upload this data. So when you're out in the field, you collect it and it goes straight to the cloud. And this is done on a tablet that the district has, and they upload it automatically and it works like a charm. So it's automatically linked to the cloud. And at first, we were doing this exclusively through Survey 123. But the issue with that is that whenever you collected a water quality parameter for a point, it created a new point on top of the point that you were collecting. So it was essentially stacking points throughout time. So we didn't want that because it essentially serves as a weather station and as a similar thing to think about. A weather station is one place and it collects data over time. So the solution and workaround to this issue. The web map that was used for the survey had to be linked to the points via field maps. And then this link automatically brings up the survey once you click on the point, and then it is saved to the data table in the cloud. And I'm going to demonstrate that right now. So you use your mobile device. In this case, I'm going to use a cell phone. But let's see.
Up the share. On the little device up there, the little screen, set it to the dot cam.
Oh, I see.
Yeah. Set it to dot cam. Dot cam. Okay, there's your phone, and what you can do is you can do, hey, everybody looking at, oh, won't show the dot com.
All right. Well,
They're just gonna have to trust you out there.
yeah. So everybody in Zoom land, I'm sorry, but it doesn't work for sharing the screen. So here is the water quality map. This is in ArcGIS field maps. So I want to collect a point at the main pump station. So I just click on the point. And then I scroll down and I go to the survey. And then I select my station, which is already there, my station name, and then the date, and then time. And then I'm just going to leave these default values here. And then all right. Submit. Easy as that.
Set that back, the pad, set it back to the.
All right. And then you verify your data collection. So
You can share that. So stop the sharing that. You can share your ArcGIS online.
okay. And then you would go here. Refresh it for good measure. And then there it is right at the top. Test, 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 defense. Simple as that.
Make sure you're sharing the PowerPoint again. The Zoom.
All right, yes. I believe the Zoom can see that.
And move your mouse onto that page.
All right. So finally, the discussion and recommendations. Although we're trying to optimize the data collection service for the irrigation district, it's still a good practice to collect it with a pencil and paper. Technology tends to throw problems a lot, so it's a good thing to do. This tool can help the districts for decades to come. The technology will only improve, and it'll make data collection even easier. For similar projects, which there are plenty of similar projects out there like this, The key thing is to make sure that your data compilation and cleanup is correct, and it takes the longest, and it is essential to make sure that it is correct, especially for location-based testing sites. And then a recommendation more for the irrigation district is that more testing sites should be added on the west side of the district, specifically on the main canal. There's a large cluster of drain outflow sites on the eastern side of that main canal, but there's not a lot of control points on the main canal. And then to wrap things up, cloud-based GIS services help to better collect water quality data for GCID in a more efficient way. The workflows are a lot cleaner and eliminates human error, and it just makes life for the technician a lot easier. Visualizing the data is a key part to this project so that the GCID engineering department and the general public can make observations about certain data points. And if a landowner has an issue with that, if they suspect water quality, the irrigation district can go out and they can test it and they can make a decision from there. With that in mind, there's also an expected water quality standard to be upheld. And it is both the responsibility of the district and landowners to be stewards of this water that is provided to them. This eventually all does go back into the Sacramento River from the natural drains that are in the district. So with that in mind, it's best to keep that practice. And then finally, irrigation water quality management systems are a way to track changes in water quality and a way to visualize how those changes can affect the surrounding infrastructure, environment, and wildlands. Any questions?
First, we'll give it a little clap. Okay, Don, we'll start with you.
I'll go ahead and start. I'm like trying to formulate my thoughts right
Okay.
now.
So just to clarify, Matt, what time of the year did they collect data?
Yeah, so they collect data from their water season is from April to October. So they mainly start on April 1st until October 1st, which is they try and do it on a monthly basis. However, it's not always consistent. So if you were to do a data regression or anything like that, you would want to do that with month year. Similarly, they also, if they can, they will collect water in the off season from November to March. That's just icing on the cake for them.
Growing season. And the other question is, before this project and was Glenn-Colusa Irrigation, did they have a GIS? Were they using Google Earth? What were they doing before if they were just storing all this data in binders, and how were they even managing the district before?
So they're the Glenn-Colusa Irrigation District, they were storing, are you talking about water quality or just GIS in general?
GIS in general. How are they working with any of this?
So the water quality data was just always stored and housed in Excel and Access. And if a regulatory agency asks for it, they could provide that water to them. Another thing with that is that they generally had GIS through Google Earth, and they've been transitioning in the past few years from Google Earth to ArcGIS products, which is mainly what we work with now, but there are some Google Earth things.
So this is really formalized things for them, putting this all together.
Correct. And it's a great opportunity for them because they learn more about, it doesn't have to do with water. The parcels that they serve, who is pumping groundwater in drought seasons, how drought affects them using remote sensing and LiDAR and things like that. So it's a great tool for them because they can do a lot more and they can have a better analysis.
And they're gonna make this system public, right? They wanna,
That is the end. Yes, that is the end
they
goal.
wanna be able to show the farmers and everything, here's the data we've been collecting, here's what it looks
Yes.
like over time.
Yeah, it's all public data at the end of the day.
Okay.
So
So this will be the first time they're really kind of opening their books?
I wouldn't necessarily say that just because it's more so it's more available in the sense that you want to go to the office and ask for it.
Right, it's all available online now.
Yes. Yes.
Okay.
Yeah.
That's all good. On?
Yeah, I'll start with maybe the easier one. Go from there. So I guess one question is can the system work offline? Like I know there's some
Yeah.
end zones out there.
Absolutely. So that was one of the big things that I was trying to figure out. And Field Maps has a setting where you can work offline and then, but you also have to make that connection to the URL. So you have to make that URL applicable to offline settings as well. The only time I haven't run into many service connection problems much, but like the only time I have, it's been in orchards. So just there's a lot of trees. But once you get out, you have a decent connection, so it'll automatically upload still.
Okay.
Yeah.
Yeah, I was thinking about that because I know that there's some dead zones out in the district, you know, where
Oh, yeah.
even though it's flat valley, like
Right.
there's no cell coverage in some spots.
Absolutely. Yeah. And that was my when I was trying to work this problem out with Esri, that was one of
Major
my
consideration.
yes, exactly. It was a huge consideration.
And then another question, because you mentioned the access database, like I'm wondering in terms of the interface of that older data that's been uploaded, how have you been able to integrate that into this product you developed here?
Yeah, so all the data is housed in here from 2014 to present day in ArcGIS Online. So that was kind of the main idea. It's just to keep it all in one place. Sure, you know, it's great to have it in Excel and Access, but if you can just go, okay, we're gonna go in Arc Online, and you map it. You can make you can even extract it and make a geodatabase from it if you wanted to. So that was my main idea, is to just have it on the cloud, have that service available to people.
So the next piece is thinking like that map that you showed, the data collection points has a bunch of holes in it, right? Of where there's sampling locations and where there's no sampling occurring. Yet the water quality problems are perhaps variable across that landscape.
Yeah.
And so I'm thinking, okay, aside from this field data collection, like how, and this is thinking beyond your project. Right?
Yeah.
Like professionally, like how would you think about these sorts of things? Is why I'm asking these questions.
Yeah.
Like what sorts of like remote sensing tools might you be able to use in this space to help fill in the voids?
Sure. Yeah.
Go to your first slide.
So yeah, we'll go here. All right. So we have here we go. This is a remote sense map. This is from 2024, which was a 100% water year. The 100% water years tend to look like this, and this is color infrared. So those are bands 4, 5, 3, and they the red, pink is the healthy vegetation, and the green is the either unplanted or it's dead. So one great year to look at is 2022, and it's going to be in my paper, but it's not in the presentation. I'm kind of sorry that it isn't, because it's almost a mirror image. It's green, which means that it's unplanted and it is just not in use, and that goes for the wildlife refuges as well, because they rely on the irrigation district to get their water. So with that, you can kind of make predictions on what your water year is going to look like. Another interesting thing that I found out was that in 2014 and 2015, those are still pretty bad drought years that were pretty similar to 2022. However, the map looked very similar to this with a little bit more green and blue. My thought on that was groundwater pumping was more available. In 2022, there was almost no groundwater pumping. So it was
Sigma.
yeah, so the Sustainable Groundwater Management Act really put an end to groundwater pumping in the area. Another interesting thing that I noticed with that was the trends in salinity, pH, and water temperature for those years, especially salinity. It was way higher in 2022. And my thought with that was that if they were pumping more groundwater, there's more minerals in that water, and that still drains out to those outflow sites, and it's has a higher salt content.
So I'm thinking maybe even beyond like salt, you know, like with a warming climate, like there's outbreaks currently along the California coast of harmful bacteria, algal blooms and that sort of thing.
Yeah.
I'm just kind of curious, like how you might foresee the application of different RS, remote sensing technologies for tracking like water in the canals for, say, the refuge to avoid that kind of thing.
Yeah, I would have to explore that a little more, but that's actually a really cool thing to think about. Yeah, I think because right now I'm thinking of like the Salinas area. There's a high agricultural presence there, and it's right on the coast, and they do a lot of groundwater pumping. So one of the things they're concerned about is saltwater intrusion. So salinity is a major factor there. So having a remote sensing model that would show like changes in vegetation type would probably show that best. Actually did a project for Nori last year in remote sensing. That was my study site was Salinas, and I did a land use and water cover index. So it was mainly blue and yellow, and it showed that pretty well. So that's definitely a tool that can be used.
Okay, we'll open it up. Any questions, audience? This is your chance to pepper him.
I'll ask questions.
Go on, Gary.
Were you the one doing all the data collecting? Was that your job? All that too?
So for my internship, I was actually hired for a different project, and I kind of convinced the irrigation district, said, "Hey, can I do this?" And they were like, "Yeah, sure, why not? Like, it'd be pretty cool." So, yeah, I was originally hired to do what's called the inventory, the GCID inventory update. So they had points of water quality infrastructure throughout their district, and it was all on Google Earth. So there's about a 200 to 300 foot error on everything. So with better GPS systems now, we go out there and collect a point and goes automatically into the cloud from field maps. There was some data management that needed to be done, but it was just more of a housekeeping thing. And then in terms of water quality data collection, there's another engineering technician who does that. However, I've been tagging along with him to start learning the ropes and learning the route, because some of those places are pretty remote. They're pretty out there, and it's very easy to get lost. And a lot of places look very similar to each other. So yeah, I think there's some activity in the chat too. So let's see what's going on.
Online questions.
Oh. Sorry, yeah, my boss is actually watching too. He was also saying they used ArcMap prior to, so it was Google Earth, ArcMap, ArcPro. So yeah, like it just gets better over time. And And then back to your question, Don, about remote sensing, and now I was referencing to 2022. They have 825,000 acre feet of water that is allocated to them every year by the US Bureau of Reclamation. In 2022, they got 18% of that water. So that's another reason why that was almost a mirror image. So their water allocation is dependent on what they get from the federal government.
Valley Project.
Yeah, and then I got a question from my boss. What do you think would be the best way to present this data to the public so that people can get the most out of it?
Make it public and share the link.
Yeah, so yeah,
On the
this
webpage.
yeah, posting the dashboard on the webpage would be great. It's playing around with ArcGIS Experience Builder might be a good way to do it too. I'm more familiar with dashboards and Experience Builder. So that'd be another good tool. And having it's just an easy way to have quick access to everything that a landowner and the irrigation district would need. There are multiple departments in the irrigation district office that use this data, so it'd be great for them too.
You know, I don't know if they have like meetings with people who are recipients of the water within the district, but that would be, you know, like if there's a regular meeting that.
Yeah, so there's
There too, right?
there's an annual landowner meeting right when the water year starts, so this would be a great tool to show them too.
I'll just.
I'll go with Jen first.
Well, no, I was just gonna say, I was just gonna build on that too, as far as like, say, I don't know, duck clubs or other stakeholders.
Yeah,
who would be
absolutely.
Interested in that.
Yeah, and that's great for them because they're the managed refuges and wetland habitats. And even in the wintertime, most of those areas become, especially because it's rice, they become wetlands, and they just kind of sit fallow with water in them, and there's plenty of ducks and duck hunters out there who enjoy that. So yeah.
And cold.
Nori?
If you have time, more time for this, if you have a project presentation a year from now,
Yeah.
how would you improve your dashboard and also survey 1, 2, 3, like that?
I would improve the dashboard by making sure the actions are dialed up. But I think having a better way to zoom to the point. I remember I got it to work and it zooms directly to the point and it'll show just the attribute information and then it'll pull up the data too. I think that's one thing I would change. One thing about the survey that I would change. I think just adding more control points on the main canal, especially for the southwest side of the district. It's a little bare in terms of that, but getting there logistically within a day would be really hard.
So they do all this within a day, all 20 points in one day.
Yeah, the idea is to keep it all in a day just so that
Consistency,
there's a
yeah.
consistency in the data collection process. And that, you know, if you collect data on March 20th, but you didn't finish, you only got to point 17. If you have to go back on March 21st, well, the weather might be different, the time's different. And there are other environmental factors that could, you know, affect that water quality for the day.
Odie?
What's that?
Oh, just I had a question, curiosity, basically. Would it be possible to set the survey data entry system to set some threshold, like based on the average or historical data set?
Sure, yeah,
Somebody
yeah, there,
use, degrees Fahrenheit instead, so that
Yeah.
sky high or outside this range, That's
Right,
it.
yeah, and
To warn them, hey, stupid, have you checked?
yeah,
That way, just they don't have to enter some outlier. point.
right, yeah, and so like I think some sort of like a warning system would be pretty interesting. I would definitely look into that.
Actually, I think you can probably.
Yeah.
Really put in some sort of historic, some boundaries.
Yeah, like and set like a threshold because I know like there are some if we go back, let's see what's going on. Try. If you go back this slide here. So like this is the temperatures in Celsius. You know, if it somehow was 76 degrees Celsius, I really want to know how hot it was that day. Just because that's really hot. But yeah, I think that'd be a really good tool to have, especially with salinity too. So I'm kind of curious, like if that was from like a pesticide that was dropped in the area and the chemicals reacting with the water, that could be it. It also could be crop type too, because there's also a lot of tomatoes that grow out there, and tomatoes are a really acidic crop. So tomatoes, like when they fallow out, they kind of just let the plant die and that water just kind of flows out. So that could be another reason why too. But yeah, I think that'd be a really good idea to set some sort of a threshold and go out and kind of make an investigation as to why it changes. I have a question in the chat. Don, do you have a question?
Got it.
Okay.
Take it back.
All right, one more question for the chat. We're gonna wrap it up.
And then can this tool be connected to an in-place sensor to live readings?
That's what I was thinking of.
Yeah, I think it could.
Yeah, you can.
It definitely can. And this is something that this is my boss asked this question. We actually looked into this a few weeks ago, and they're expensive sensors, but it'd be really cool to see that.
So I mean, I was thinking about this because we haven't installed them yet, but we have like these water level sensors and things like that we can put in wells. And so
Yeah.
like there's temperature sensors, there's all kinds of different ones.
Absolutely, yeah.
Onset makes them, you can link them to a weather station. You could have, if you've got 20 sampling sites, you could have 20 weather stations potentially
Right.
that would record data, and like there's just a constant logging that then you just send somebody out to either collect it or it uploads to satellite or cellular or whatever.
Yeah, I'm pretty sure the sensors that we were looking at, they can update automatically to a database system. And then from there, the world's your oyster. You can do kind of whatever you like with it. Yeah, the only thing you'd have to do is just maintain them. You have to clean them, I think, every 90 days.
Yeah.
Just so that way the sensors are getting accurate readings.
And that is going to be a problem, Don. Applications, they break down, they don't update, and there's a missing data. Happens all the time.
Yeah.